We've already seen that a carbon atom with tetrahedral geometry, which is bonded to 4 different atoms or 4 different groups, is known as a chiral center. And a compound with a single chiral center can exist as 2 enantiomers, or 2 mirror images of one another, which is a type of stereoisomer. So how many chiral centers does a glucose molecule contain? Well, let's take a look at glucose. Glucose is a pretty important chemical, and glucose, here's the picture of glucose on the slide. It has 6 carbon atoms. It is actually an aldose, and our number 1 carbon, which is the aldehyde carbon, is not chiral because it's not tetrahedrally bonded, and our number 6 carbon is not chiral either because it's bonded to 2 hydrogens. So let's look at the 2 carbon, which is chiral. It's bonded to this alcohol functional group and hydrogen, and then an aldehyde functional group, and then the 1, 2, 3, 4, 6 4-membered carbon chain here. So 4 different groups. If we look at carbon 3, it's also bonded to 4 different groups, and to the right, those 4 different groups are sort of highlighted. So the first group that it's bonded to, according to this designation, is the carbon 2 and the carbon 1, and then the second group is the hydrogen, and then the third group are the 3 carbons in the chain below it, and then the fourth is the hydroxyl. So each of these groups is different, so the 3 carbon is chiral as well. And if we go through this systematically, we will see carbon 2, carbon 3, carbon 4, and carbon 5 are all chiral because they are bonded to 4 different groups. So glucose has 4 chiral centers. Now, the number of stereoisomers increases with the number of chiral centers in a molecule, and the general formula for the total number of stereoisomers for a molecule is 2 to the n, where n is the number of chiral centers present. And because glucose has 4 chiral centers, 16 stereoisomers are possible, but only one of these stereoisomers, D-glucose, is our preferred energy source. So this slide shows the 16 stereoisomers of glucose, and this is not something that you'll have to reproduce, but I just want to point out that the top 8 are the only ones that occur naturally, and the bottom 8 are the mirror images of the top 8. So if we look at this first one here, its mirror image is right here, and its mirror image down here does not exist naturally. If we look at the second stereoisomer of glucose, its mirror image is right here, and it does not occur naturally. So only 8 stereoisomers occur naturally. Stereoisomers of glucose, that is.